This is problem number 1 from section 9.4. In this problem, they want you to use Gaussian elimination with backward substitution to solve the following system of linear equations. They give you a system, but this is a two-variable system, so two equations, two variables. And they want you to use Gaussian elimination to solve it. Gaussian elimination is similar to regular elimination. The only difference is we ignore the variables as we do the elimination. So the first thing you have to do when you want to use Gaussian elimination is you want to make what's called an augmented matrix. And you'll see that this is a three-variable augmented matrix. The two-variable augmented matrix is just going to not have the third equation, of course. And then it also doesn't have the third variable. So it's just x1, y1, put that there, x1, y1, x2, y2, and c1, c2. Now, these stand for the variables from the different equations. So x1, y1, and z1 are the variables of the first equation. x2, y2, and z2 are variables of the second equation, so on and so forth. And these are the constants that the equation is set equal to. So this bar stands for the equal sign. So here's what an augmented matrix looks like. You'll see we took the coefficients from the first equation, negative 15, negative 3, and negative 12, and wrote them out. And then we took 6 and 1 and 5 and wrote them out for the second equation. Now this column stands for the x values. This column stands for the y values. And this column is the constants. Now as we go to solve this, all right, our goal is to, just like when we solve equations, we want to get one x equal to something and one y equal to something. We want to get an identity matrix is what this is called. But we want one equation to have just one x equal to some constants, and the other equation to have one y equal to some constants. So we want to solve this down to this part being the identity matrix 1, 0, 0, 1, so that we can find our solutions. Here's how we do this. We're going to write these out step by step. I always like to cancel the bottom left corner. I'm going to kind of leave that up here. I want the bottom left corner to be 0 first. So in order to get the bottom left corner to be 0, I got to multiply the top. Let's see, if I multiply this by 2 and this by 5, I'd get there. So I'm going to take 2 times row 1, and then I'm going to take 5 times row 2. So I multiply the 2 through, and that's negative 30 minus 6 minus, that'd be 24. You got to make sure that your multiplications are good, so you might need to use a calculator as you do this. 5 times 6 is 30. 5 times 5 is, 5 times 1 is 5, and 5 times 5 is 25. Now that I have these set up, I'm going to cancel this spot here by taking row 1. So I say row 1 plus row 2, and I say equals row 2. So whenever I say I'm taking row 1 plus row 2 equals row 2, it means I'm adding this with this row. It doesn't change the first row, but it does change the second row. That's why I say equals row 2. So negative 30 and 30 gives me 0 for the bottom left corner. This is negative 1, and this is 1. And then on top, I still have negative 30, negative 6, and negative 24. So now I want to get the bottom right to be 1. That just means multiply negative 1 times row 2, and I can rewrite this as 0, 1, negative 1, and this is negative 30, negative 6, negative 24. Now I just need to cancel this top term right here, and I've got this 1 here, so I can multiply the bottom by 6. So I'm going to say 6 times row 2, and I can rewrite that. And when I multiply that, I get 0, 6, negative 6. Top is still the same, negative 30, negative 6, negative 24. Now I'm going to take and write row 2 plus row 1 equals row 1. So I'm changing row 1. 0 plus negative 30, that's still negative 30. 6 and negative 6 is 0 here. Negative 6 and negative 24 is negative 30. And I still have 0, 6, negative 6. So now I just need to multiply the top. Well, I need to divide it by negative 30, but I like to just say I multiply by a fraction of negative 1 over 30 times row 1. And I do the same thing on the bottom, 1/6 times row 2. And as I do that, that gives me 0, 1, negative 1. And it gives you 1, 0, and 1. So that tells me my x value, right? Because remember this column's x values. X value is 1, so x equal 1, and y equals, because y here, negative 1. So my coordinate is 1, negative 1. And that's the solution to this problem. That's how you use Gaussian elimination to get there.